who is very reputed. He has set up the Department of Engineering Design at IIT Madras, and he's currently working on getting medical sciences and technology together in a new department at IIT Madras. So let's give Professor Krishna Kumar a warm welcome. And he's going to speak to us for about 20 minutes and inform us about what's really happening. I'll leave it at that.
Thank you, Narayan. So, I have attended hostel nights at Gora.
Okay, honorary member. Okay.
Yes. That way I have attended hostel nights and other hostels. So I get joined. And for a change, we will talk about real neurons. So, for a change, we will talk about real neurons, real intelligence instead of artificial intelligence and neural networks. So we got interested for a change in the human beings as well. So this is a new Department of Medical Sciences and Technology, which was just inaugurated 15 days ago. And let me talk to you about what this department is, why this department was started, and what's our vision and what's our goals. We feel that the future of computer science is medical science and technology. So we thought that it is time IIT Madras looks at this very closely with a vision which our state is to develop world-class research environment and education in medical sciences and technology to produce well-trained physicians, scientists, and technologists. So our goal is to look at physician scientists as well as scientists who are working on medical sciences and device developments and so on. We'll have a look at that. So why is that we need this department? Why is this department formed? We want to populate the bridge between medicine and engineering. For example, biomedical engineering has existed for a very long time. That's supposed to be the bridge between engineering and medicine. But biomedical engineering really did not achieve what it's supposed to achieve. No one crossed this bridge between medicine and engineering. Most of the biomedical engineering engineers ended up being electrical engineers, electronics or computer science people, but their understanding of medicine was not to the level where they can really contribute in diagnostics and other protocols. So we feel that there should be a program which marries medicine and engineering, and that's why we started this department. So there are a number of reasons, especially India-specific reasons, to start this department. So one of the things is that develop a mechanistic understanding of the prevalent non-communicable diseases. This is very much needed in India because recently, for example, WHO just announced that there are 100 million people in India who have diabetes. 26% of the population has hypertension, and there is an ethnic basis to these diseases. So the research in these areas, there's a crying need for research in these areas, and we feel that a department like this, with a background of research from IIT Madras, would really contribute to these understanding, mechanistic understanding of these diseases. Based on this, we want to see whether we can develop effective treatment protocols, build capacity for biomedical devices. One of the things, as I just now explained, is the design of medical devices, understanding the physiology. The country imports about 85% of all the devices, and we feel that here is an opportunity where we can contribute to a national need. So that's the next thing. And then Of course, we have talked about AI, ML, we talked about data analytics and so on. I've been working in this field for some time, and I can assure you that if the physiology is not understood, if pathology is not understood, if diagnostic procedures are not understood, the scatter in the data will scare you, and AI ML is not going to be effective. So in other words, whoever does data analytics should have some background and experience in physiology. And so, with all these needs, we thought that a medical engineering education, combining both, that develops high quality talent is important. That's the reason why this department was launched. So these are things which I've already taught. So what is our unique offering? Now, why is it that IIT Madras enters medical education? What is our background? Can we really contribute to medical education or medical research? So let's look at a few of the problems, and you get to recognize the amount of engineering and technology in these problems. Surgical planning, minimally invasive surgery, neuro, cardiac, etc. The technology is very high. We talked about AI a lot. For example, autonomous vehicle uses, say, reinforcement learning. It's exactly what minimally invasive surgery as well uses. So, engineering content of all these problems, digital twins, and therapeutic planning, artificial organs, stroke research and rehabilitation, artificial kidneys, where membranes for ultrafiltration becomes very important, robotic surgery, fracture healing. There are many mechanical engineers here. You may be happy to note that, I don't know how many of you remember, octahedral shear stress theory. A few of Manish's here to whom I taught, maybe he remembers octahedral shear stress theory, and that's used, and that's very important, for example, for fracture healing. So the tie-up between engineering and medicine is so high that we don't have a wall today. And that's why we thought it's time that IIT Madras enters medical education. And then disease networks. A lot of concepts from computer science is used in understanding disease networks. What is the connection between diseases? It's a big topic. I just want to leave it because of the lack of time. Artificial organs. In fact, this is an area which is going to be very important, not in the distant future, immediately. In fact, I'm in a conference here in SF, American Society for Artificial Internal Organs, and I met one of the top guys in this field, Harvey Borowitz. So when you explain this program, in fact, he volunteered to come to IIT Madras, stay there for a couple of semesters, and teach courses in this. Because of the type of program we have put up, he was very happy to contribute to this. Because the challenges are huge, costs are very high, technology required is very niche, and so artificial organ is an area where a place like IIT Madras can really contribute. Digital twin, my lab works on digital twin, so I know some amount of the technology that's involved in digital twin. We can reproduce patients in the computer. We can use them to understand what-if scenarios. You can, in fact, use them to do some clinical trials and protocols. So, digital twin, which has a lot of concepts coming from AI, can be used here, and this will define the future of medicine. Understanding the molecular basis of human disease. These are some of the, I would say, problems which take us very close to medicine and breaks that wall. So what did we do? We realized that this kind of program should be by the doctors, and should be run by, and the output from these should be useful to the clinicians, and so the guidance should come from the doctors. So what we did was to form a committee, a steering committee, an advisory committee consisting of all the top clinicians from the city. So here are the list of names. I don't know how many of you are familiar with the health canvas of Chennai. You would notice that if you know it, you would notice that most of the top doctors in the city are members of the steering committee. So this is the committee which guided us in the whole program. And now they are all professors of practice in IIT Madras. So we had international visiting faculty. Both of them are engineer doctors. I don't know, some of you may know Professor Venkatraman Sadanan, 1977 B.Tech Electrical, went on to do neurosurgery. He's a neurosurgeon right now in this area. So, so these two people again were key advisors in putting together this program. Then we had an international advisory panel which participated again in guiding us through these programs. So how did we form this department? This department of Medical Sciences and Technology is formed or is structured in a similar fashion that of a hospital and a medical school. So we will have Center of Excellence for Nephrology and Neurology, Cardiovascular Medicine, Orthopedics, Ophthalmology and so on. So this would be the centers, and these centers would be tied together by some fundamental work on physiology and translational research as well as medical imaging. So the department would be structured in the same way as that of a hospital. So each of these centers, for example, I've taken cardiovascular medicine. In each of these centers, we will have 4 legs to this. One is that a hospital is tied up, I'll come to that in a minute, to these centers. Hospital is very important, so hospital is tied up to these centers. There will be engineering faculty, there will be doctors who are also faculty, and then we are bringing in a corporate house to be a part. For example, Gajendra, you have talked to them, they will set up a center of excellence inside these cardiovascular medicine. So these will be the 4 arms that will form a center. So this kind of structure exists in each of the centers which I just now said. So the centers will have both engineering as well as clinicians, engineers as well as clinicians. And that would bring us closer to understand the disease pathology as well as the diagnostics and treatment protocols and so on. So the department was inaugurated on May 11th, this 2023, by Mr. Lakshmi Narayanan. We're grateful to Lakshmi Narayanan who gave immediately 100 million rupees as the startup grant, seed money for forming this department. We have one of the most important infrastructure that is needed for this department are the hospitals. Because we want the students to spend time in the hospitals to understand the practical or tie the theory to practice. So we have tied up with a number of hospitals in Chennai. We have signed an MOU with all the hospitals. Many of the doctors whom I had just showed the previous slide, they work in these hospitals. So their units will be a part of this department. So you can see many of the corporate hospitals, which are well-running corporate hospitals, are a part of this department. So what are the academic programs that we have introduced? We have introduced a very interesting BS program in medical sciences and engineering, an offline on-campus program. There's some confusion that BS is an online program, but I want to state that this is an on-campus program. This program aims to develop what are called as engineering physiologists. So they will learn human physiology from the principles of from the lens of principles of engineering science, such as conservation, mass, momentum, and energy. So to understand that the body can be very well understood from principles which are studied in mechanical, chemical, electrical engineering and so on. It's like looking at an automobile, not a steel metallurgy, which is what the biologists do, but from a design which actually encompasses the whole functions of a car. In a similar fashion, we can study a body, and that is very important for the future of medicine. So we are going to introduce anatomy, medical imaging, diagnostic technique, develop mathematical models which would form a basis for cardiovascular and respiratory mechanics, gastrointestinal, etc. So then also understand the interactions of these systems through models and case studies. So how is the structure? We have a fundamental science block where we teach the students mathematical models, engineering mechanics, biological sciences, fluid mechanics, finite element analysis, immunology, microbiology, biochemistry and so on. So this forms the basis for further build-up, okay, of medical sciences. In the next stage, after the students of PS program are taught the fundamental sciences, then we build the medical sciences where we teach the neuroscience, cardiovascular, respiratory mechanics, introduction to surgery, where the students will see surgery live, understand the difficulties, understand the technology that's involved, orthopedic biomechanics, nephrology, gastroenterology, endocrinology, and so on. So this will be taught, each of these courses will be taught by an engineering and a medical faculty, and they will spend half a day in the hospital to understand cases and see how what they have studied in the courses is used to diagnose and treat the patients. Once they do these two, they are ready to specialize. So that is what I call as the specialization basket, where device development, now that they have understood physiology, organ-specific device development becomes much easier. There will be 5 courses where some fundamentals that are required for device development will be taught, as well as organ-specific device development will be taught for these people, for these students. AI/ML and data analytics, they will be now ready to go into AI/ML and data analytics. With 5 to 6 courses, because they know the physiology and other nuances of medicine, their understanding of AI/ML would be much better than any other person who just enters, who uses AI/ML. Surgical robotics, drug discovery systems. For example, we will have PK/PD, organoids, human on chip. These are the type of courses which we would do it for drug discovery. People can also do fundamental work in medicine, physiology, biosciences, and so on. In other words, at this point of time, having understood the macro picture, they can do biology if they are interested, or they can go to any of the other fields. So this will be the flagship program, or PS program in medical sciences and technology. So what is the outcome of this program? They can do organ-specific device development, artificial intelligence applied to health, medical image analysis. There will be a number of courses on medical image analysis, quantitative pharmacology, drug design and deployment, translational research, or fundamental physiological sciences can be taken up as a career for research. So this in a nutshell is their path, which I had already defined. The admission process is not through JEE, but through an ICER entrance exam, which ICER is the now Indian Institute of Science, Education and Research. A lot of students who are interested in fundamental sciences take this exam, and so we are going through ICER aptitude test, and the number of seats at 30, we have already, till last week, the number of applications were more than 3,000. So 1 in 100 is the type of student selection that will go through in this course. So we also have a doctoral program in medical sciences and engineering, which will commence in January. So here we want to have physician scientists. In other words, doctors will be taken up for a doctorate program, and there are a number of reasons why this is happening, or this we would like to. I don't have time to go through the details, but I would say that many of you here may understand the importance of physician scientists. 37% of Nobel Prizes are physician scientists, along with many Nobel Prizes in chemistry. In other words, a lot of research are done by physician scientists, and we feel that it's time that a place like IIT Madras has a program on PhD for physicians. The interesting US experience shows that nearly 90% of the people who have taken this program would like to do it if they were given a second chance. So there's been a lot of satisfaction in the United States at least, and this is very new to India, and we feel that we will also get this kind of statistics when we launch this program, or after we launch this program. One of the things that recently the National Medical Commission has introduced is that people who teach in medical institutes, medical colleges, should have a PhD. So the PhD is being rare. There are not many places where they can do PhD. We feel that the gap can be filled by a place like IIT Madras. And you can see that in the United States, about 57% of people who are physician scientists are in academics. And again, this is a very important statistics for us. So this is our program. The PhD program we will admit MBBS, MS, MD, DNB. That's the first PG as they call it. Then super specializations, DM, MCH, and others, they can do PhDs. As well as direct PhDs from BTech and MTech can also do. In other words, this department will, as I keep telling, break the wall, and we will have both engineers as well as physicians. And that cross-pollination, we feel, will have a very impactful research environment for these people. So, how is that we're going to model this program? We will have a mirror PhD program. So, clinicians are always very innovative because of their profession. So, if you look at it, we will split this PhD into concept to bench and bench to bedside. So, the bench to bedside part of it will be done by a clinician. Concept to bench will be done by an engineering student. So in other words, completely from concept to bedside can be covered by 2 mirror PhDs. So that would be very effective because some of the conceptual understanding may very well be given by an engineering student. And many doctors are actually want to be entrepreneurs. That's happening in this country, that's happening in this city. So many doctors have come to us and said that we want to start, companies, startups with concepts that they have developed. We would also offer the science behind their conceptual understanding of clinical protocols, and we would like to offer an entrepreneurial PhD for these people. Of course, type of doctors, there are a number of them. They want to work in machine learning, and we would welcome them to do a PhD without any of the first 2 things. So this is what we have done. So these are the key milestones. We have launched the department. I will show you, we have already got a space, 45,000 square feet for the department. We will have about 14 to 15 labs. We have academic tie-ups with 7 hospitals. I just now showed them. We have MOU with them. We have launched the PS program. As I just now said, 3,000 applications for 30 seats. Faculty recruitment is ongoing. 9 doctors and 4 of us are members of this department. PhD admissions will start next time in January. MD PhD, MD given by the medical university by Sri Ramachandra Medical University nearby. They will give the MD, MS program, and we will give the PhD program. So that will also start in January session. So our key milestones so far has already been reached. We are looking at the future. So that's the new department. One full floor in this department, in this building rather, has been taken up by our department. That's about 50,000 square feet, 45 to 50,000 square feet of area. So we want to have, this program should have long-term impact. Should have, we want to be a pivotal stakeholder in the national health mission. We want to educate, with a fundamental, because many of the doctors are still protocol-based. So we want to bring science to some of their protocols. I've been doing this. It's very interesting to know that many concepts that we use in engineering are actually used in medical protocols and diagnostics. In fact, I'm working with one of the ophthalmologists, and she treats keratoconus, and she uses what is called stress strain index. So I had to take a 3-hour lecture and actually explain what is stress and strain. She said that I don't know anything of it, but when this number is more than this much, I do a UV, treatment. Then I had to explain to her what actually is stress strain index. So it's a very deep concept. So in other words, we want to train doctors along with the understanding science in their own field, and which we feel can be done with the background that IIT Madras has. So we want to create ultimately world-class physician scientists, and we definitely are aiming at a Nobel Prize winning research, not now, maybe in the next 15, 20, 25 years. But we have to start now. So this is an ambitious program of the future. So what's required apart from, we have all said, we are about to fly, we are on the runway, we have got everything going as far as the key milestones are concerned. So our next step is to have medical education in IIT Madras. Maybe 7 years, 8 years down the line, can we have an MS, MD program, MCH program, MBBS program, and so on? Because in that case, we will start training them right from the beginning. Right now, we have a PhD program, and the MS, MD programs are actually given by, the degrees are given by other universities. But if you want to have a complete, understanding, then we feel that we need to train them right from the beginning. So our next step, the future, is to go into these things. Future in the sense that next 5 to 7 years, we should enter into medical education as well. We have already prepared a number of things on this. This is the hospital which infrastructure, a key infrastructure. Okay, we have prepared a complete plan for a hospital. This is the artist's view of the hospital. A complete design has been worked out for the hospital. This is the super specialty hospital which we are planning, and we are looking for funding. It's a 600-bed hospital which we would like to have as a part of our research program. Floor plans are ready. Even what is to be purchased in each of these specializations are ready, including the pins that has to be purchased, required, have been worked out. So a complete plan has been worked out, and that's the type of budget that is required in order to establish a hospital which is a research-based hospital. So we have done all the framework. Now whatever is required, we have already done all those things. So to conclude, we have a vision. It's very clear now what we want to do. We have expertise, we have a number of doctors, we are already recruiting very good youngsters as assistant professors. We have the plan, I've shown that to you, and we have pushed it in the past. All these things have been done in the past 6 months. So we have the will to do it. Professor Kangodi is giving an excellent thumbs up to this program, and so we have the leadership. What we need are the resources. we need research to do a lot of stuff. So we want to define the future of medicine. We would like to invite you to be a part of defining the future of medicine. This is the type of funding that we are looking at, and I will leave it at that. And I hope you would consider, some of you would consider this more seriously. Thank you very much.
Thank you, Professor Krishna Kumar, for sharing this new information. I mean, when you said it's just 2 weeks ago it was announced, it's really hot off the press. So that's very encouraging that your visit here is very timely, and I'm glad that you could talk to this august audience in this room. I'm sure there are batches who are doing reunions who will say, hey, this is a great thing for us to do something about. So all of you who are doing 10, 20, 30, whatever the marquee years, maybe something that they would like to consider. Okay? Thank you very much. Is it okay to share this with the people, or is it confidential? You can send me a shareable version, because I'm sure that some of the people who could be here and the larger audience that is here, right? I think it's very...
Can we take 1 or 2 questions?
One, let's limit it to one, because there's a panel waiting and there's food waiting and that's all. We are really behind time. We can do it during the social hour. Thank you.
So I'll just go for one question very crisp.
Okay. Go for it.
The decade of 2010 to 2020. My question is, the cost of drugs and products which are on patent here in US, which are very useful. Example is a diabetes product like continuous glucose monitoring system could be Abbott's, Libre or a Dexcom thing, along with the feedback of the insulin. It's very expensive for India, so obviously it's not available for the general market. But
Today it's available.
Today it's available.
Yeah, it's available.
So in general, the vision you have here, is it possible that the research you have here will bring fruit in the future, and there could be negotiations both sides, US and India especially, to have research both ways shared?
Yeah, we want research labs to be established. We are talking with Pfizer, for example, to have a research lab here in this department. So we are talking to Johnson & Johnson, getting in, Blackshear, and all these people. See, the advantage here is that we have all the top doctors are part of this, and they are bringing many of them, and that makes my job easier as well. And so we feel that we want to form this as a center of excellence for research in medical sciences. So in that way, it is not, the aim of this department is not to do re-engineering or the aim of the department is to do research, and we want products to come out of that research. So we are not an entrepreneurial department. We are a research department, academic department, from which research will throw out products. Thank you.
Thanks again, Professor Krishna Kumar.